Alright, chapter 11.6 is getting into something called confidence intervals. A confidence interval is an estimate of a population parameter stated as a range with a specific degree of certainty. They would need to be written down for use today. You don't need to use all the words as long as you attach the number 90% to 1.645. I think I actually give you those numbers in your homework though too. So actually they don't need to be written down at all, so I wouldn't worry about it. But remember that this is your standard deviation, and so for 90% confidence interval, it means that in your standard deviation you're talking about a distance like this. For 95% you're talking about a distance that's a little bit wider, and for 99% you're talking about a distance that's even wider than that in terms of your percentage. So sorry you couldn't see it. This was your 90% or something like that. Let's just imagine that's 90%, so you have that area. That would be more area, which would be your 95%, and then that would be your 99%. So if you wanted to catch more people, then you use a bigger standard deviation. That way your curve gets a little bigger. Again, keep in mind the standard deviations from the mean. The higher the deviation, the higher the percentage of population included. The lesson pretty much requires two formulas. Now these I would write down because they won't be on your homework. But the error estimate E, which is Z times S over N. I don't know why they do this to you, but S is standard deviation and N is the number of your population. And then your confidence interval, which is CI, is the mean, I believe. Hold on. Yeah, your mean or your average, which again they're switching your numbers around, plus or minus whatever your error is. So if your error was 5, then you would take whatever it was and add 5 and subtract 5, and that would give you the left and right side of that. Formulas aren't difficult, but you must be accurate, otherwise, like I said, you're probably going to miss it. But I don't see any real issues with this lesson. I'm glad it's kind of like I'm glad it represents the last lesson that we're going to do, because I will tell you some of these things were killing me in terms of having to read up and practice and make sure I knew what I was talking about. A poll of 218 randomly selected members of social networking websites showed they spend an average of 14 minutes per day on the site, with a standard deviation of 3.1 minutes, created a 95% confidence interval for this average. First off, you've got to know what your confidence interval number is. I'm sorry, what your Z is, and in 95%, if you look at that, 95% is 1.96. You don't need the zero. And so we will do our error estimate, which is, I believe, Z times S over square root of N, which means that it's Z, which is 1.96, times S, which again is your standard deviation, which is 3.1, over your number of the sample, which is 218. Now if I'm going to type this in, I'll probably type this into my calculator and then multiply by 1.96. That way I won't make any stupid mistakes like I always do. So 3.1 divided by square root of 218 equals, and then times 1.96. Rounding that to 2 digits, I believe, is 0.41. And then your actual confidence interval is whatever your mean is, which is 14 plus or minus that number. And so what you will see is, after we do this, sorry, minus first, what you will see is 13.59 less than, I believe I put mu or x, I don't know which one I used, which is less than 14.41. These are the only two numbers you have to find. Those are the only two numbers you have to put in. So it's really not that bad. Again, you just simply have to make sure you know what to do with that stuff. Make sure you pick the right Z or the right number for Z, depending on your confidence interval amount. Plug it into your calculator correctly. Again, for me, the safest thing to do is to get this number taken care of, because I can always do times 1.96, since multiplication is what they call commutative, and we know that 2 times 3 is the same as 3 times 2, which means I can move that number to the front or back and still be safe. Sample of 200 students was asked the average time they spent on homework each weeknight. The mean time was 52.5 minutes with a standard deviation of 5.1 minutes. Determine a 99% confidence interval for the population mean. Again, the first and most important thing you have to do is identify Z. If you want a 99% confidence interval, 2.576 would be our number. So that would mean that E is going to be Z, which is 2.576 times S over N, so standard deviation over the square root of the number of samples. And again, I'm going to go ahead and type this in, 5.1 divided by square root of 200, just be careful, 0.36 times 2.576 gives me 0.93. And so what I am looking for in terms of your confidence interval is your mean, which is 52.5 plus or minus 0.93. And so I do 52.5 minus 0.93, which gives me 51.57, less than your mean, which is less than 52.5 plus 0.93, which is 53.43. And I'll explain now. In terms of what this means, it means that we are 99% certain, confident, that students spend between these numbers here. The other one would say we are 95% certain that talking about people who spend a certain number of minutes per day, we are 95% certain that people spend between 13.59 and 14.41 minutes per day on their website. So again, your confidence interval is just giving you a range that you are this percentage of certainty certain of that's where the majority of your population is going to, or that's where your population is going to be. Doesn't mean everybody's going to be there, because in this one there is a 5% chance that if you randomly ask somebody, they wouldn't be there. But in this one, there's only a 1% chance that if you ask somebody, that the student wouldn't be at that range. So again, your confidence interval is just telling you, you know what, I'm pretty sure that people, 90% or 95% or 99% of the people are in this range here. Just one more example, and that's it. 40 managers at a tech company were asked the average number of days they worked. The average was 9.1 hours with standard deviation of 1.1. Find 90% confidence interval. Again, the first thing and most important thing is identifying Z, which is 1.645. And so you know that your E, error value, is Z, which is 1.645 times S, which is your standard deviation, which is 1.1, over square root of the sample. Now, when I first read this, I had an issue, but notice that the number 40 is just hidden in that part there. And so with that, we now want to type that in. By the way, the importance of this number, if you remember what we've been talking about during this chapter, is that the higher this number is, the better off it is for you, which is why you notice as you get a bigger number here, you're going to divide by a bigger number, which is going to make the overall E smaller, which means that your range will be more compact. If I only sample 2 people, then you're going to get a bigger number here, which is going to make your range a lot bigger. So again, 40 people versus 100 people versus 4 million people is going to make a difference. But just keeping in mind, because you do at some point want to be able to just kind of use your common sense on questions like that. Not so much for the answer, but just to kind of get an idea of what should be happening. 1.1 over 40, yep, times 1.645 is 0.29. Confidence interval is going to be your average, which is 9.1 plus or minus 0.29. Okay, and then so we just type those in, getting 8.81, less than your mean. Again, I'm not sure if that's it, but I do know you only have to put those numbers in. 9.39. So we are 90% certain that the tech company managers average between 8.81 and 9.39 hours. Is that per week? I don't know. But anyway, that's the general idea. That is your last lesson of the year. I hope you realize that the specificity of the last two sections, there will be lessons in your math life that require a lot of analysis, where you just have to learn how to look and read. I didn't like those that much, and there will be lessons that require muscle memory of a process. I love those because once you get the process down, for example, I know from just doing the examples that you simply take z times s over square root of n, and then you take the mean plus or minus whatever that error is. The only thing I haven't memorized is the confidence interval numbers, but again, that part I loved. You might be asked to memorize a few key values, 90%, 95%, 99%, whatever the z would be. If you were asked to do the percentages on normal distribution, for example, if they want to know where the middle, I think it's 68%, whatever it might be. But the processes aren't extremely difficult once you've done that necessary work. As I told you already yesterday, this is the last lesson of our year. I appreciate the hard work for this year. Speaking mostly to Merrick, to Evelyn, and to Alexis, who, from my observation, have been with me since we went on this break, and I appreciate that because it's not an easy thing to do, especially when you know that no one's watching. But that does show a lot of discipline, and I'm proud of you three for doing that. Some people were close, but like I said, I think from what I saw, those three are with me right now, and they'll actually be finishing this class on the 28th, because I am telling you three, those three I named, Evelyn, Merrick, and Alexis, that you may quit now, because for the most part, this stuff doesn't need to be mastered. It just needs to be seen, and there's no need in getting your scores up. You have an A. You three, that was. The rest of you, I guess you need to make sure you do what you got to do, because anyway, I wish you the best as you move on to your high school career. Remember that the only thing promised is that you'll face frustrating lessons on occasion, as you saw in here, but as long as you continue to push, I can promise you that you will get through it. It is actually worth it in the end, as I have learned that every mountain climb simply gives us more confidence for the mountains to come. I do hope I was able to prepare you for the rest of your school careers and lives. Take care and enjoy your summer. Grades, your Math XL will be posted on a district website soon. I don't put those in all the time because that's a lot of things for me to have to change, but I think, check them out about once a week. So other than that, again, enjoy yourselves. Thank you for your hard work, and take care. Let me know if you need anything.